Now it's my pleasure to introduce our keynote speaker, Dr. Donald Bosch, Professor of Maritime Science and President of the University of the Maryland Center for Environmental Science. He is the author of 2 books and more than 90 scientific papers, and his expertise and advice are sought on the regional, national, and international level. Dr. Bosch was appointed by the President to the National Commission on the BP Deepwater Horizon oil spill and offshore drilling, and served on the National Research Council's committee that produced the report, America's Climate Choices. His efforts have been recognized locally with the Outdoors Maryland Award for Stewardship of the Environment from Maryland Public Television for 2010. Thank you for agreeing to speak to us, Dr. Bosch.
Great. Thanks very much, Susan. I've been privileged to speak at 2 other League of Women Voters events, and it's just they always have such great audiences and really engaged in the discussion and in the learning, collective learning, because I learn a lot from talking with you, as hopefully you learn from me. I also want to thank Barbara, my friend here and colleague at Chesapeake College, for hosting this, and Greg for putting this on as well. When Chesapeake College and League of Women Voters invites me, at the same time, I can't say no. So I'm here today. So what I'd like to do is to help you understand something about our main topic today of sea level rise. The fact that it's occurring, the fact that it is going to, we have very strong reasons to think that the rate is increasing and will increase even more into the future. Help you understand why that's the case, to help you then try to say, how do we put all this information together so that we can develop projections of what we are going to be confronting in this region? And that would lead to a responsible planning and action to address the consequences to our communities and to our region. Now, the main thing you need to know about sea level is that historically, into the deep Earth's past, recently and into the future, it is primarily dependent on the Earth's temperature. We'll let you know why that's the case. So as the world has been warming, sea level has been rising. Now, I think it would probably, on many of your minds, is the fact that it is bitter cold out. In fact, we broke records yesterday for cold temperatures. So how can we talk about warming of the planet? And I'm not going to go in and give you a lecture about why the climate is changing and the greenhouse gas effect and all of these other kinds of things. But I do want to, on my mind as well, I grabbed this image last night from a NOAA website. And what it shows is the anomalies, which are the variations from the long-term average for the for the 3 days leading up to Thursday, as it turns out. That was the last that had information on. So this cold spell that we've been having, you can see it in the purple and lavender blue colors as a severe anomaly of some 30 degrees at the maximum below the normal temperatures for this particular period. So also, just on this map of the United States, you'll see at the same time, to the west, it's anomalously warm. So they have unusually warm temperatures, ranging up to 16 degrees Fahrenheit warmer than usual. What this tells you, I want you to understand this in 2 ways. First of all, is that this pattern is caused by an unusual incursion of air that normally resides over Canada and even Siberia into our region, but that cold air isn't expanding, it's just moving. So at the same time, we are having record cold temperatures. The west coast, Alaska, last year had record warm temperatures. And northern Asia is having very warm temperatures. So we have these variations in the climate system. In fact, this phenomenon is an area of very active research and discussion that say this destabilization of that Arctic air is a feature of the warming Arctic Ocean. That's another story, but the point I want to make is that while we may be seeing very cold temperatures, the nation as a whole is not. And secondly, the last month, January 2015, was the second warmest January on instrumental record since we've been measuring temperature around the world on a global basis, and 2014 was the warmest year on record. That's just a one month, 1 year shot of a very long trend, which is quite robust. As the scientific community says, this is unequivocal warming of the world that we've been seeing. So sea level rise. We know that sea level is rising from a whole variety of indicators. The one that's most clear and relevant is that one of the longest time series of tide gauge records in the United States is in Baltimore. Baltimore was a historic port, so they started making tide gauge measurements of the tide. These tide gauge measurements are made on a station which is a piling driven down to bedrock. So it is not moving. It's not an artifact of the fact that we've been changing, had an unstable reference point. And we can see that in this, basically the 20th century, we've had about a 1 foot rise in sea level. Now, that is sea level relative to that tide gauge and relative to the land around it. As we'll see, there are multiple components of this, and the one in particular that we need to pay attention to is the fact that the land moves up and down. I mean, it changes its elevation over long periods of time, and in our region, we're sinking slowly. So part of this, about half of this record, is due to the sinking of the land. It's why this is relative, and half is due to the rising of the ocean. So if we go back in time and look at sea level historically, first of all, sea level is varied greatly, hundreds of feet in level of the ocean historically. And it's had a number of reasons why this is the case, but in the last million years or so, the large variations have been due to glacial cycles, so ice ages, we might call them, that have occurred on about 40,000 year intervals. Now, I won't go into exactly why there are these ice ages, but it has something to do with the movement of the Earth and the orbit of the Earth around the sun that gives us more or less insulation over very long time cycles. So we were at the peak of the last ice age about 20,000 years ago. And so this is what our region looked like 20,000 years ago. So I just marked up here where Salisbury is, up at the top, so you can get a reference. There was no Eastern Shore. There was no Delmarva. We were well on fast land, hundreds of feet above sea level, and there were these big rivers that freely flowed through incised valleys that entered into the ocean at where the edge of the continental shelf is. So if you wanted to go to the beach, go down to the beach, go down to the ocean, as they say, you'd have to go 67 miles farther than Ocean City is to get to the ocean. It's only 20,000 years ago. So since then, of course, that great mass of ice began to melt, and it began to fill up the ocean. In addition to that, as we'll see, it got warmer, so the actual volume of the ocean expands as it warms. Those are the two primary components of sea level rise that you need to kind of understand. So as we see, as this ice age ended and sea level rose quite rapidly, marching across the continental shelf, and about 8,000 years ago, 8 or 9,000 years ago, it began to fill with ocean, brackish water, the lower end of what we now know as the Chesapeake Bay. And so you can see we still didn't have the bay near us, where if you were located here, and that continued to rise. Now, mind you, it had risen something like 400 feet, so that pretty rapid rise had already occurred, so it was slowing down. And about 5,000 years ago, it kind of began to slow down, and yet the bay continued to fill with water over the next several thousand years. And the reason it began to fill with water is the land was sinking. So the ocean kind of rate, as we'll see, rate of rise began to slow down, but we still had a bigger bay because the land of that slow rate of land sinking. Didn't take much, doesn't take much, because you see from going from the 5,000-year level to the 3,000-year level, it's just, 10 to 20 feet of difference of the water level relative to the land. But this is what created the bay, sea level rise. So even in the recent history, we have good records of loss of lots of communities and islands that occurred in the bay that were well established and ended up succumbing to this rise of the water level. Now, to the individual observer, even today, if you go to people at Smith Island or Tangier and ask them what's going on, they will talk about their land is eroding, because what they see is the waves eating the land away, so they want some barrier to protect that. But ultimately, that erosion is driven by the relative rise of sea level. And just a seawall, just a hardened shoreline, is not going to protect you from that over the long run. So here are some examples. Sharp's Island. This actually is not a picture of turn of the century people. These are guys who went out and dressed as if they were living in the turn of the century and stood on the last remnant of Sharp's Island. Right now, it's actually just like help me, the name of the island here, the Poplar Island. We are now thinking about quote restoring that island as a way to deal with dredge material from the channels, to recover land mass, and also deal with the dredge material. And then I think you're probably very familiar with this picture of the collapse of the last house on Holland Island to the south of us in 2010. So this has been going on a while, and it is accelerating. Now, I talked about the fact that we're sinking slowly. Again, about 6 inches, a little bit less per century. Why is that the case? So here is a map of the world that shows you in red the areas that were heavily glaciated, that was massive amounts of glaciers during the last ice age. It's just hard to imagine the mass and volume and weight of this on the land surface. These glaciers were many hundreds of feet thick, thousands of feet thick. And what happened is that exerted pressure, that mass exerted pressure on the Earth's crust, and just outside of where they occurred, it had the effect of pushing the land up. I like to give the analogy of, although, yeah, people over a certain age, you will get it. Talk to younger people, they say, what? A waterbed. You all remember waterbeds, right? So if you're sitting on a waterbed and a big fat guy goes on the other end of that, sits on the other end of that waterbed, what happens to you? Bulge up, right? And if it gets up, you go down. So that's what we're doing when that big glacier on the other end of the waterbed got up, except that we're talking about not something as easily fluid medium as water. We're talking about rock, and it takes a while to adjust. So this is what's going on. There are some other causes of land sinking due to human activities. For example, groundwater withdrawals can cause more rapid surface sinking of the surface of the land. This is thought to be a factor in some parts of this region. Down in the lower part of the bay, this is why Norfolk, for example, is having even a very severe problem of higher relative sea level rise than we're seeing. It's also thought to be a problem in and around Cambridge because of the large water withdrawals during the period in which we were dependent, that economy was dependent on canning, large water use from withdrawals from groundwater. So as that mass has been lifted, the areas in red, the formerly glaciated areas, are now rising. And we are now, in the blue areas, are now sinking. So on top of that long-term problem, I mentioned that as the bay flooded, it got to the point a few thousand years ago where basically the water of the level of the oceans basically leveled off. So here is a record of that based upon some very clever analyses that scientists did, collecting a variety of measurements from salt marshes, including some nearby in the Chesapeake Bay, in which they, through clever use of the fossils, the little shelled organisms, the protozoans that live on the surface of the marsh surface, they could locate and date, but using radiocarbon dating, where the water level was back in time. And so these reconstructions showed that over the last 2,000 years, sea level has been relatively stable around the world, and seen only a period of about from 1,000 to 1,500 years ago where sea level rose at a little bit faster at a rate of 0.6 millimeters a year. And then actually began to decline a little bit to minus 0.1 millimeters a year. So in this 2,000-year period in which most of our cities around the world were built, most of our civilization developed its relationship to the ocean and the coast, shipping occurred, we had the land movement aside, we've had stable sea level. We thought it was always going to be that way, right? Well, what happened is that beginning in the late 19th century and really accelerating into the 20th century, as we'll see, sea level began to rise at rates not seen since the post-glacial period when the ice was rapidly melting and sea level was marched from 67 miles off Ocean City to where it is today, of about 2 millimeters per year. Doesn't sound like much, but relative to what we've observed, it's truly significant. Now, this is a messy slide. This is a very new research, so I grabbed it, and I want to draw your attention. These are a whole various scientists. This shows you an important scientific process, and that is scientists love to have fights. So one guy publishes something, he's got a curve of what they project sea level to be. Another group comes in, has a new technique, a new method, new data sources, they develop their estimate. So it's all a process of constant improvement. So what you can see, I want to draw your attention to sort of the orange line at the top, which is the most recent estimate that makes some corrections from what the other guys didn't do. And it basically shows you that, as I said, during the 20th century, on a global basis, we had 6 inches rise in sea level, or mentioned the other half of the foot was due to sinking in our case. But that in the more recent period, post-1990, that curve tends to tick up, like a ski slope going up, and even faster rates. In fact, coincidentally, around a few years later, in 1992, we began to develop the first measurements of sea level that were not dependent on tide gauges. Tide gauges have a problem because there are only a few of them around the world, and of course they're on land masses that are rising or sinking, so we have to correct for that. These measurements are made from satellites. So we have now satellites, 3 different satellites over the period that have been flying that can very precisely measure the distance between that satellite and the surface of the Earth. And since they're continuously circling, they can survey not only the coastal regions where we have tide gauges, but the whole ocean, and can do it on a regular basis. So we have now really robust understanding of sea level rise from these satellite measurements. These are global averages, and here we see a rate of 3.2 millimeters per year, from essentially 0 to 2 to 3 millimeters a year, and as we go well into this century. So with that, I hope you're convinced that sea level is rising, and it's been rising in recent years, recent periods, last 30 years or so, 50 years or so more rapidly than it has been. So what does the future hold? How do we make projections about what that future condition might be? Do we just extrapolate that line, or do we know the processes that contribute to sea level, and can we apply those locally? So there are a number of factors that affect sea level. One I mentioned is the expansion of the volume of the ocean due to heating. And that's been the primary cause of sea level rise, this recent rise that we've seen over the last 120 or 30 years or not. So very consistent with the increased heat, increased temperature in the surface of the ocean. The second one, and a very important one, is the extent to which these glaciers, like the glaciers that occurred during the Ice Age that sit on land, melt, and that water flows into the ocean. Most of those glaciers, of course, we're in an interglacial period, are gone, but we do have some of great significance. They sit in mountains, which we know are melting fairly rapidly. But most importantly, they sit on Greenland in the Arctic and in Antarctica in the Antarctic. So the big feature here about how rapid the rise will be, it depends on how degree to which and the rate to which those big ice masses melt. Not a simple thing to measure or to estimate for a variety of reasons. First of all, at the same time they're melting in some places, they're increasing mass in others because snow falls on them, and if snowfall increases, that could increase the amount of ice going onto the land. A bit complicated, but we're learning a lot more about it. So those are the two big factors, but in any given place on Earth, there are some other factors that we have to take into account. First, we have the land sinking issue that I mentioned, all right, which we know a little bit about here from our region. The other is that the sea is not level. We call it sea level, but it's not level. There are differences in the elevation of the ocean around the world. Important differences, and there are differences because of the differences in the temperature and expansion, but there are also differences just in terms of the currents that are flowing. The currents will have a tendency to push water up in some places and take it down in others. So we have to factor that into what we know as well. In addition to that, there are other areas in which there are other places in which water is stored on the continents, on the land, and kept out of the ocean. An important one of those. So as we, for example, build dams, we can trap water and not keep it on land and not get into the ocean. The other is groundwater abstraction. So if we take water out of the ground, and if that water table declines, that's adding water from the continents to the ocean. So all of those things have to be kind of taken into account. We know that the ocean is warming. Most of global warming is ocean warming. 90% of the increase in heat that's been seen over the last 150 years or so has been increased in the ocean. Simply because, if you heat water, it keeps its temperature for a long time. There's a heat capacity to hold heat as opposed to air. So this is the real kahuna in terms of what the long-term climate system is going to be like. Here we have this remarkable record that now shows us this really upward movement in the heat content of the ocean that is very consistent with the expansion of the volume of the ocean to use. So we know that component pretty well. We also now know that the polar ice masses that we talked about in Greenland and Antarctica are declining. How do we know that? As I said, it's difficult to even measure, much less forecast. We know that because, again, these remarkable tools that we now have from satellite measurement systems. These satellites, a pair of satellites flies together, and they can measure the gravity field under where the satellites go. So if you have a change in the mass of ice, the gravitational attraction on those satellites will be diminished over time. So from that, we can measure this change in ice mass, the mass of ice on Greenland and Antarctica. So we know this is occurring, and we also see, you can see those curves are sloped downward. That means the rate at which they're losing mass is accelerating. So we can actually then getting better to understand the models for that. So the $64 trillion question is how much will the seas rise? This is, again, a recent a bit of scientific work by a group of experts in this field who have surveyed all the other experts to come up with what we call expert elicitation. And they asked them what was their best projections for sea level rise over this century, the rest of this century, and under two conditions. One is that if we go as business as usual, as if the concentration of greenhouse gases in the atmosphere, which we know pretty absolutely positively, 100% surely will increase temperature, then not do much about it, we continue to grow our global economy, continue to grow emissions of these greenhouse gases, what would be the case? Or if we slammed on the brakes, if we did what we could possibly do, everything we possibly could do to reduce those reductions. So you can see in this slide that the first question, the first component of, and it's bigger than the scientific uncertainty, the range of the bars, these banners in color. The first thing that it depends on, us. So the amount of sea level rise that we will have to plan for and experience depends on what we do with respect to greenhouse gas emissions. But within that, you can see that there are some significant differences by the end of the century. And I didn't want to overload my presentation, but if you actually carry this into the future, in the next 200 years after them, the differences widen. In other words, if we're going to stabilize or at least keep sea level at a more manageable level, it depends on the emissions that take place over the next 30, 40 years. There's nothing that my grandkids living in the 22nd century can do about it. It's already in the system. It's already, the greenhouse gas is there, the warming's taking place, the glaciers are melting. It's already done. So we have a responsibility not only in terms of the conditions that we need to manage for, but subsequent generations need to manage for as well. So what this tells us, these are in metric, these are in meters, but generally what they're saying is that unless we slam on the brakes, we will have very likely over 1 meter, more than 3 feet of sea level rise globally. That's global sea level rise. Now, as I said, the big factor, the big bit of the uncertainty is how much the polar ice sheets will melt. We're learning about this every day. Papers come out that just this end of last year, you might have seen something in the news about some discoveries that Antarctica, the issue there is not so much melting as we think. Water of this ice melting on the land and dripping down into the ocean, but the undermining of ice sheets which are sitting on the edge of the Antarctic continent because the ocean is becoming warmer under them. So that's going to destabilize very large masses of ice that could come back into the ocean, just as an example. The other thing, which I think is paradoxical, hard to people to understand, counterintuitive, is that what the consequences to you are of Antarctica melting versus Greenland melting depends on where you sit. And the curious thing about it is that you would normally think, just intuitively, that if you were close to Greenland, the sea level would rise more rapidly than if you were farther from Greenland, and exactly the opposite is true. And the reason is that, remember I told you about the mass we're measuring from satellites, is that mass is reduced. Not only does the gravitational attraction between that satellite and the land mass is reduced, but the gravitational attraction from the ocean water to that mass is reduced. So if it's reduced, the ocean water relaxes. It's not pulled toward the continent as much. So we can factor that in, and we did in developing these analyses. The other factor, remember I mentioned the ocean currents have an effect as well. And we can see that here we have off of us the Gulf Stream. Gulf Stream is a massive amount of water flowing off of the Carolinas, turning to the east off of our coast. And what it does is it basically pulls water off of the continental shelf between where the current flows in the land towards the ocean. So literally, if you went out on the average and measured the sea level at Ocean City and you went out to the other edge of the Gulf Stream, there'd be about a foot of difference in that water level. So if, as is likely to happen, that current slows down, that force that's drawing the water slows down. So what happens on the water on Ocean City? Goes up. Okay, so that has to be figured in as well. Here's some evidence of that based upon analysis of tide gauge data, including the ones in the Chesapeake Bay, that shows over periods of time the velocity of the Gulf Stream does affect our water levels here. And I think this research is ongoing, but there was this very alarming trend at the end of this record to show a reduction in the strength of the Gulf Stream and an increase in tide gauge levels. This, as you might have seen, it was published about 2 years ago, got a lot of attention about the mid-Atlantic being a hot spot for sea level rise. This is the presumed reason why. So we put all this together. I don't want you to read the numbers here, but the point is that we looked for 2015, 2010, getting our best estimates, all the components, thermal expansion, glaciers on land, Greenland, Antarctica, this dynamic current issue, as well as the sinking, the vertical land motion that came out with our estimates. And here is what we produced. And these are being used, as were done at the request, actually, of an executive order by Governor O'Malley, and are being used in the planning. You'll hear more about from Zoe Johnson here now. So by 2050, our best estimate is 1.4 feet of sea level rise based upon a year 2000 benchmark, and by 2100, 3.7 foot. So basically, we expect to see, this is with land sinking and so on factored in. So basically, we expect to see more sea level rise in the first half of this century as we saw in all of last century, and perhaps 3 to 4 times as much sea level rise this century as we saw last century locally. There are enormous consequences of this. This just a map to show you the shading of elevation. So you look at it this way. The light blue areas are salt marshes down in Blackwater Refuge and Point South, and you can see they're obviously immensely susceptible. The greens are areas that are within 2 meters of the mean tide level. These are susceptible over this time period to inundation and permanent inundation, and then the orange and yellow levels are 2 to 4 meters. So these would be the areas which would be additionally susceptible to storm surge. You know, Hurricane Isabel Cambridge, we had about a 7-foot storm surge. That's on top of a changing baseline for sea level. In addition to that, it's going to have major consequences. It already is to the bay. The volume of the bay is going to increase, just like we showed you it did when the post-glacial period, transgression of the water into the coast. It means a greater ocean influence. Salinity gets higher because if it's not counteracted by more fresh water inflow. And in addition to that, we're already seeing signs of all of these consequences. People think of, 2050, oh, this is what the water level is going to be. You think it's a step function, but it comes in small doses. So already, even in normal weather events, the extreme storms aside, we're seeing increase in what's called nuisance flooding. Annapolis, and for the period 1957, 1963. Here, here's the city dock and the Kunta Kinte, Alex Haley statues. Only less than 4 events per year. Over a more recent period, this should be 2011, 2013, 39 times a year. And if we take this into the future, this is a publication that actually tried to draw projections for a variety of areas, coastal cities in the U.S., and you can see Baltimore, actually, as it turns out, Miami, Florida, has almost exactly the same profile as Cambridge, Maryland, in this figure. The dark blue areas, just a few days, or the number of current events per year. 2030, you'll see the increase, and then by 2045, you see the increase. So you can see that many of these places that were even colonial towns built because they were close to the water but were dry are going to become increasingly inundated as the water levels fluctuate. So and you'll be hearing a lot more of this as the other session leaders give their presentations and set up the discussion. But if you think about it, what can we do about it? First of all, I want to make the point that I showed you that map of the eastern shore and the colored coded the flooding levels. The eastern shore, Delmarva is not going to go underwater. It's around the edges, and it is compared to a lot of other problems we must deal with, particularly in those related to climate change. It is a manageable situation. It's a question of we have to make wise decisions to protect us and our interests, and to protect the future of the future generations as we deal with it. There are basically 3 options. We can avoid or retreat from areas that are going to be inundated. Don't build in areas that are going to be inundated, or actually think about moving people and moving things from areas that are not going to be difficult to sustain. We can protect them by a variety of approaches to protecting from extreme flooding events. We'll talk a little bit about that. And we can, if we're going to live in vulnerable places, we can increase the resilience of those places and how we build and live in those areas. And these are the topics you'll be discussing today. This is from one of Zoe's reports showing that really what we need to think about is really integrating all of the things we need to manage for. Transportation systems, our roads, thinking more broadly across the bay, the port, rail systems, all of those things are vulnerable. Shoreline buffer and buffer management have to be part of the process. Land use planning, actually knowing where you can site things or not site things. Building codes, which increase the resilience of our infrastructure. Freeboards, elevation levels, electrical infrastructure, sewage, all of those kinds of things. Natural resources management, how do we manage the natural resources? In this area, particular challenge is how do we manage and sustain coastal wetlands, because they're going to be susceptible to this inundation and loss. Even though managed effectively, they have the capacity of actually accreting, just like I mentioned, those scientists able to use that fact to reconstruct sea level rise. So they can, at certain levels, continue to grow upward and accrete. And emergency and disaster response, all of those need to be integrated. Particularly this issue of wetlands. We have to think of as sea level rises, they will tend to migrate back over what areas that will be fast land as they are regularly inundated. Wetlands can establish. How do we allow that to happen while also dealing with personal property issues and interests? And then as we think about the various methods to protect ourselves and our infrastructure, there are a whole variety of approaches. Some of them are structural, like concrete and things like that we build, levees, storm surge barriers, and the like. Others, we can use natural systems to give us some level of protection. Wetlands is one of them, dunes, oyster reefs, and the like. All of those, I think, need to be factored into our approach. And just throw this in to think about the scale and consequences of this. These are some examples of massive, massive investments where people already have in place or are planning or talking about things to keep the sea out, particularly during storms. The one on the upper left is in Rotterdam. That can close when you have big North Sea storms. Thames, and to protect London, now has these big gates that can close when water levels rise. On the lower left is the protection system built post-Katrina that protects the eastern flank of New Orleans, the areas where that surge came in and flooded the city. Again, allowing transportation through it under normal circumstances. This is the intercoastal waterway. But also allowing it to be closed when needed. And then active discussions actually about possibility of a storm surge barrier guarding the New York Harbor. There's even been some suggestion, it hasn't risen to a big level, it's hard to imagine the cost, much less the side effects of a storm surge barrier that would close the mouth of the Chesapeake Bay, if you can imagine. I don't know how you even begin to estimate the cost, but it would have enormous consequences to the bay as we know it. I'm very proud that in Maryland we are very progressive, thanks in particular to Zoe Johnson and of course her bosses who was let her do this in developing what we now call smart adaptation. We have in law now requirements that state investments and state agencies have to take this sea level rise into account in both siting and design guidelines. We have, and the idea here is to do what we can from the state perspective and lead by example so that local communities can also begin to learn and apply some of these same approaches. And through our program, we're developing multiple tools available for planning and decision making that are available. So I'm happy to, hopefully we have a few minutes to entertain any questions or comments you have. Thanks very much for your attentiveness. Don't be shy. You're going to ask a question. I saw the hand going up like that. Okay. The presentation? I can certainly make it available. I don't know if you have the capacity. We can put it on our website as well. Oh, yeah, that's right. We have written questions.
We have a few written questions, and feel free to write your questions out and signal our runners here who will bring them up to us. As for this is being live streamed to some locations, and I understand there will be a DVD available, but I'll have to get that word to you a little later in the day. Perhaps Professor Farley will know more about that. But here's a couple questions, Dr. Bosch.
Oh, thanks. How can scientists best use the media to convey clear, consistent messages to the public? Or is this possible? I think it is possible. I spend a lot of time doing that, actually, and I think one of the ways you do that is just like I tried to do today. That is to take what is really pretty complex science and put it in terms that you can more easily understand. Not be alarmist, but be realistic. to let people know what they can do to prepare for this future, but also let people know what they can do about shaping that future. So this is an area where there's one of the interesting parts about this topic of climate change and sea level rise is that it's because it's become so polarizing. Somebody gets so much attention and so much unusual amount of criticism of the science. Scientists have stepped over the boundary and said, we need to become more effective communicators. And so there are many leading scientists who are very good at doing this. Various programs, you can just go online and find all kinds of Union of Concerned Scientists. All sorts of organizations have some simple ways to understand it. What I decided personally, after being involved in that National Research Council study that was mentioned, Susan mentioned, and having it go nowhere with respect to national policy, is that this is forever. This is a long-term problem, and as a person who was just having young grandchildren at the time, I decided I'm going to set aside part of my time on education. So I do a lot of work now with trying to develop the foundations of understanding the science in our school system so that when these kids become responsible adults, they can use this understanding in their own lives to make personal decisions and collective societal decisions. What's causing the Gulf Stream to weaken? Very good question. What drives the Gulf Stream is a number of forces, physical forces in the Earth, the rotation of the Earth, but one of the principal ones is that when that warm water goes up off of Greenland and around Iceland, and it's the reason why Europe has a mild climate given its latitude. But then in the winter, then it cools, it sinks. It becomes more dense, and it sinks. So as the world warms, two things are likely to happen, in fact, are seeming to happen. First is that the cooling of that water is less, so it's not sinking as much. And so that sinking drives the replacement effect. So it's like a conveyor belt, and it's one of the gears in that conveyor belt. The other is that as the ice in polar regions melts, seawater is a little bit fresher, which of course is less dense, and so it doesn't sink as much. So that's the conveyor belt idea. And there was a sensational movie some years ago about how that could, just put everyone in a deep freeze. New York under, with, frozen and that sort of thing. That's not going to happen, but it does have a role in the changing climate. Okay. Well, related to that, specifically, what would be the loss of the Gulf Stream's power have on the British Isles, specifically the weather? The best climate models, regional models, global models that we have suggest that Europe generally is not going to freeze as a result of it. It's going to be moderated by the warming of the Earth, but that the northern areas, northern Scandinavia, the Nordic countries, the northern part of those actually might become colder as a result of the diminution of the strength and energy of the Gulf Stream going north. What role do the saline currents play in regional temperature and sea level rise? Well, by saline currents, I'm thinking you mean the ocean currents, but also, as I mentioned with respect to the Gulf Stream, the salinity of the water, the salt content of the water does have an effect. Salt in the ocean and in the bay is important for a variety of reasons, one of which is that it's a main component in the density differences. Temperature and salinity affect the density of seawater. So as salinity increases, the water becomes more dense, and salinity decreases, it becomes less dense. So in that way, that changes in the salinity, in the saltiness of the ocean, do play a role in ocean circulation and therefore in the warming of the ocean and regulation of the climate. I feel like the Johnny Carson routine, you know, what is that? From a live stream. Oh, hello out there. What are recommended land uses for local jurisdictions? This is actually will be a topic, I think, of discussion in the breakout groups. But siting issues, I mean, this issue is going to have to be, sea level rise particularly, is going to have to be taken much more seriously into siting. Right now, we use various federal codes and requirements by FEMA and others that regulate your insurance and so on, but those are generally retrospective. They're based upon recent past, and they're not prospective. And so the whole approach here that we're taking in Maryland is that let's use prospective understanding of what sea level rise may be so we can make appropriate land use. It's going to affect on the shore not only, you know, development uses, but also agriculture. So there are some low-lying agricultural areas that are at risk as well. So I think this will be discussed, but under the topic of siting, it's a very important component I think we need to take into account. Isabel, what more could have been done? Well, I think, you know, the last big flood, storm flood in Isabel, in Chesapeake Bay, occurred back in the 30s, of that same magnitude. And of course, we knew little about what was going on, and you know, we really didn't learn the lessons from that storm. And so when Isabel came, we were unprepared. We didn't make adequate forecast of what happened, so we were surprised. So that jeopardized people and getting out, public safety, and so on. We didn't have building codes that anticipated this. So what's going to happen, and will happen from, you know, whether it's Katrina, Sandy, is that when these incidents occur, we have to get smarter. We have to get smarter about how we plan for the future. So they're mainly wake-up calls that can help us deal with that. So I think we're out of time. I'd be happy for any of those who had a question that I didn't get to get to answer. I'd be happy to talk to you at the break. Thank you so much. Appreciate it.